Hello, students. How are you all? Very good morning, very good afternoon, very good evening, whenever you are watching my videos. Now, in today class, we are going to start one of the very important topic, and the name of the topic is SN1 mechanism. And one of my students, that is YouTube students, where he is learning the things online, he asked me that, sir, I am not able to understand Lucas reagent. So after dictating SN1 mechanism, because Lucas reagent is directly connected with SN1 mechanism. So I will dictate all the things regarding Lucas reagent as well as SN1 mechanism in this video. It doesn't mean that Lucas reagent has some different things, same thing. Lucas reagent also follows SN1 mechanism. So whenever I am giving the example of SN1 mechanism, I will take the example of Lucas reagent. So in which we will complete Lucas reagent as well as SN1 mechanism. So welcome to you all in your own YouTube channel S2 classes, Subra Swarswati classes. So now, first of all, before starting the topic, I will give you the little bit discussion regarding hybridization. Sir, you are teaching Sir, you are teaching SN1 and Lucas reagent. Then why you are discussing me hybridization? Little bit use of hybridization in SN1 mechanism. So I am dictating that. Don't worry about that. Just you will have to learn one formula, that Z hybridization in detail I will teach you whenever I am teaching periodic classification of element. But over here I am teaching you little bit that is important. Hybridization is denoted by Z and its formula is number of sigma bond plus lone pair of electron on central atom. Lone pair of electron on central atom. Suppose I have written over here, sir, what are you trying to say? I am trying to say that hybridization is little bit used in SN1 mechanism. So you will have to understand, as well as it is used in Lucas reagent. And this video is going to be little bit more than 1 hour. So please try to cooperate, because I just want to give you the detailed explanation, so you will not find any difficulties regarding SN1 mechanism as well as Lucas reagent. So first of all, hybridization is denoted by Z. It has a formula, number of sigma bond plus lone pair of electron on central atom. Now suppose I have made a structure CH over here, and suppose I have make another structure NHH, and suppose I have make another structure OHH. Now I am asking, what is the hybridization in this case? So what you will say, sir, Z is equals to sigma bond. Sigma bond means single bond. Sigma bond means single bond. How many single bond it has? Sir, one sigma bond over here, one sigma bond over here, one sigma bond over here, one sigma bond over here. It means 4 sigma bond plus lone pair of electron on central atom. This carbon is in the center, so it is considered to be central atom. And we know that every elements need 8 electron to complete their octet, except hydrogen, that will need 2 electron, that is duplet. So over here this carbon has 1 2 3 4 5 6 7 8 electron. It means 0 lone pair of electron. So Z value you will get 4. In this case, if you find Z value, you will get 1 sigma, 2 sigma, 3 sigma. So 3 plus. Now, 1 lone pair of electron on central atom. 1, 2, 3, 4, 5, 6 electron only. It means this nitrogen has 2 electron as a lone pair, and 2 electron is considered to be 1 lone pair of electron. It means 2 electron considered to be 1 lone pair of electron. So how many lone pair it has? 1. So you will get Z over here as 4. In this case, 1 sigma, 2 sigma. So Z is equals to sigma. What is the lone pair of electron on central atom? So 1, 2, 3, 4 electron only satisfied. The 2 electron left, 4 electron left. So 1, 2, 3, 4. 2 electron is considered to be 1 lone pair. Another 2 electron is considered to be 1 lone pair. So 2 lone pair. So Z is will get 4. So this is the way you can find the value of Z. And it is saying that if Z has a 2 value, then their hybridization is SP. Then their hybridization is SP. And if Z has a 3 value, then their hybridization is SP2. And if Z has a 4 value, then the hybridization is SP3. Now they are saying that SP has a linear shape. It has a linear shape. If I am writing over here, they are not shape. I am writing over here, they are geometry. So it has a linear. It means this compound is formed something like this. SP2 has a geometry as trigonal planar. Trigonal planar. So their geometry can be drawn like this. A has one element over here, one over here, one over here. And SP3 has a tetrahedral. SP3 has a tetrahedral, and it can be drawn as A, 1, 2, 3, like this. Getting my point, what I'm trying to say? Before starting SN1 and Lucas reagent, you should have to be familiar little bit hybridization. First thing, you have to be familiar that hybridization is denoted by Z. It has a formula of number of sigma bond plus lone pair of electron. If suppose I am giving the structure, it has 4 sigma. If 4 sigma, it means 0 lone pair, because one bond, one sigma bond, one single bond has 2 electron. It means 4 single bond has 8 electron. It completed their octet. So 4 hybridization, it means it has a hybridization of 4 means sp3. So if we will draw the structure of this one, so this could be originally H, 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 H. We are drawing like this, but original structure is something like that. Similarly, if we will draw the structure of this one, so one lone pair over here, H, H, and H. If we are going to draw this structure, so H, H, one lone pair over here, one lone pair over here. It is also has sp3. It is also has sp3. The first thing you will have to understand that how we will find the hybridization. Second thing, if Z is equals to 2, that is hybridization is SP and their geometry is linear and the structure should be something like that. If Z is equals to 3, hybridization is SP true and their geometry is trigonal planar and their structure is something like that. If hybridization is 4, Z value is 4, hybridization became SP3 and their structure is tetrahedral and their structure is something like that. This basic thing, if you are already know, very good. If you didn't know, so you will have to be familiar with this basic structure. After knowing this basic structure, we will have to proceed with the topic called SN1 mechanism. Getting my point? And as one of the student has messaged me, sir, please dictate me Lucas reagent again. Similarly, if you find any difficulty in any one of the topic, if you find any difficulty in any one of the topic, likewise, you can message me. I will try to dictate that topic again. I didn't have any problem. I am over here. My motto is only to make you understand all the chemistry portion that I am teaching over here. Okay, sir. After having all this bakwas sit, welcome to the topic. Now, after having the little bit knowledge of hybridization, we are going to start SN1 mechanism. SN1 mechanism. Now, sir, what is SN1 mechanism? So first of all, the full form of SN1 mechanism, and if you find my video a little bit slow, then try to see the video in 1.5x speed or 1.75x speed or 2x speed. It depends upon student to a student, but I will not teach you very fastly. So some of the student, those who need this slow version, they can see it like that. SN1 has a full form. First one, that is unimolecular nucleophilic substitution reaction. Unimolecular nucleophilic substitution reaction, or it can also be named as first order nucleophilic. This is nucleophilic substitution reaction. This is also known as first order nucleophilic substitution reaction. So SN1 has a full form, either nucleophilic substitution reaction, unimolecular or first order. Now in this first question ask, sir, what is nucleophile? What is nucleophile? So it is saying that all negatively charged particle, all negatively charged particle are nucleophile. All negatively charged particle like OH minus, like H2O. In that H2O, what you will get? H plus OH minus, like I minus. Whatever be the negatively charged particles, or you will see that is known as all negatively charged, as well as you can write as well as lone pair particle are called nucleophile. It means those particles which has lone pair of electron, like if I am writing this NH3 and it has a lone pair of electrons, so it is known as nucleophile. Suppose I am writing H2O and oxygen has two lone pair of electrons, so it is known as nucleophile. Or suppose I am writing OH minus, it is known as nucleophile. It means those species which has negative charge on their own, or they have the lone pair of electron, they are known as nucleophile. And in SN1 mechanism, first of all, we will have to be familiar that in this SN1 mechanism, we are using the reagent. Reagent is very important. We are using the reagent that is H2O, or we are using CH3OH, or we are using C2H5OH, or we are using C3H7OH, like that. Any ROH you can use, or you can use NH3 also because it has a lone pair of electron, or you can use RNH2 also because it also has the lone pair of electron, or you can use R2NH also. This is known as ammonia, this is known as 1 degree ammonia, this is known as 2 degree ammonia. Getting my point? If you didn't know, just write all the things, that this is the reagent of SN1 mechanism. First of all, SN1 mechanism is known as nucleophilic substitution reaction, unimolecular nucleophilic substitution reaction. These are the reagents, and this is all about the nucleophile. And these reagents can be done at low temperature. We will have to use the low temperature in case of SN1 mechanism along with reagent, and at low temperature this reagent acts as nucleophile. It means at low temperature, whatever with the reagent we are using over here, they can act as nucleophile. If we increase the temperature, then it will become base, that we will study it later. But we will have to use this reagent, and this reagent should be at low temperature. Low temperature means it should be less than 50 degrees Celsius. Low temperature means less than 50 degrees Celsius, like 10 degrees Celsius, 20 degrees Celsius, 30 degrees Celsius, 40 degrees Celsius, 5 degrees Celsius, any temperature but less than 50 degrees Celsius. Getting my point? So this is all about the reagent. Reagent is used as low temperature. This is all about the nucleophile, and this is the full form of SN1 mechanism. Now we are going to see what is the mechanism happening inside. All the detailing things I will try to dictate you, and trust me, if you try to see the things properly, I will not go very fastly in this topic, because trust me, after understanding all the can I erase this? If you have not taken the screenshot, you can take the screenshot over here. I just don't want to go very fastly in this topic. I just want to dictate you very easily regarding SN1 mechanism. Now over here we have completed the part regarding reagents, as well as we have completed the things regarding nucleophile and the full form of SN1. Now we are going to start the mechanism over here. Now in the mechanism, understand the things over here. Suppose I have taken RX, any alkyl halide. I have taken any alkyl halide. Now over here R is alkyl and X is halide, and over here halide should be anything, either fluorine or chlorine or bromine or iodine. And if you have studied electronegativity, if not studied, don't worry, I am telling you that electronegativity of X, and that X should be either fluorine, chlorine, bromine, iodine, is more than the electronegativity of carbon, because this R should be either CS3X, so it should be something like H, X. So now over here the carbon is directly attached with X, it means electronegativity of carbon is less than electronegativity of X, or you can say it in different way that electronegativity of X is greater than electronegativity of carbon. And you know that whenever electronegativity is more, they try to take the electron towards itself. So it will do over here the heterolytic fission. It will do over here the heterolytic fission. And because of heterolytic fission, if you are not able to see over here, I am writing again heterolytic fission, or it is also known as heterolytic cleavage. Now it will break over here and it will form R plus and X minus. It means after knowing all these things, you will get what? Something with carbon and X, it will do the heterolytic fission. Because of that, carbon get positive and X get negative. And as you have studied that positive is known as cation and negative is known as anion. And over here, there is a positive charge on carbon. So carbon is known as carbo and positive is known as cation. It means you will say that in SN1 mechanism, there is a formation of carbocation. There is a formation of carbocation. And carbocation means what? Something like positive charge. Over here, something attached, because carbon has 4 valencies. X had been removed from here. Because of that, carbon get positive charge. Now this positive charge needs something over here that can help him to get the electron. Don't get confused. Don't get confused. Please, 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 please. What I am trying to say. I have started the SN1 mechanism, and after doing the SN1 mechanism, I will come to know one point that in SN1 mechanism, X has more electronegative than carbon. Because of that, it will do the heterolytic fission, and because of the heterolytic fission, R get positive means carbon get positive. Now, positive charge wants that someone will give him the electron. Someone will give him the electron. It means if over here CS3, if over here CS3, if over here CS3, then CS3 will show plus I effect. If you don't know about inductive effect, I will dictate you, but just understand over here CS3 is giving electron and it is very happy. It means from here you will come to know that carbocation stability is more in 3 degree than 2 degree than 1 degree. Why, sir? Over here it is 3 degree carbocation, so everyone giving the electron. Suppose I am drawing 2 degree carbocation, so over here H, so only 2 side it is giving the electron. Hydrogen is not giving electron. Suppose I have draw CS3, H and H, so only one side it is giving the electron. So which is more stable? This is more stable. It means after doing the first step, we will come to know this R must be 3 degree. Just made you understand, I have written this. Now I am going to start the original mechanism. First I will make you understand that R must be 3 degree in the SN1 mechanism. If you want to write anything, write from here. I am going to erase all the things. Now come to the detailing. Part by part, just see it properly. Don't get confused. I am trying to dictate you in detailing, as well as I have already told you that if you didn't understand the topic that I am dictating, I am ready to make the video again. I will not delete the previous one, but I will make the new one again, because I love you all and I also want that you also love me from the bottom of your heart. Okay, sir, we also love you. Now from here we will start the original mechanism. It means in place of R, we are taking CCS3, CH3, CH3 and X over here. Now you know why I am taking over here 3 degree, because we know that 3 degree is more stable. We have already discussed this thing. So instead of taking directly 3 degree, first of all, I have dictated you why 3 degree, why not 1 degree. So over here we have taken 3 degree alkyl halide. Over here we have taken 3 degree alkyl halide. From here we will say, sir, electronegativity of X, and that X should be either fluorine, chlorine, bromine or iodine. Especially don't try to take fluorine and iodine, always try to take chlorine and bromine, more than electronegativity of carbon. So this electron is taken by X, and this fission is known as heterolytic fission. This fission is known as heterolytic fission. Now from here what happens? This will break and after the breaking you will get CH3, 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 over here positive, over here X minus. It means you can say that this is the first step. This is the first step, and after doing the experiment we will come to know that this first step is very slow, doing very slowly. X is going, carbon get positive. It means this is the slowest step. This is the slowest step, and the slowest step is known as rate determining step, is known as rate determining step, slowest step, because in the fast step we are not able to determine how rate is going on, how fastly it is going on, but in the slowest step we can find out that how much time it will take to complete. So this is the slowest step, first step, and rate determining step. Now in the next step what happens, the nucleophile like H2O will come over here at low temperature. At low, either it is given low temperature or not given, considered it as low temperature. It at low temperature everyone knows that H2O acts as nucleophile. Now you know that H2O, in that O has a lone pair of electron. This lone pair of electrons see the positive charge and it will say, Bhaiya, don't getting confused, I will be going to attach with you. After seeing any girl alone, you will try to make her a girlfriend, or any boys you will see alone, the girl try to make them as a boyfriend. Sir, joking. Okay, sir. Now over here, after seeing the positive charge, this lone pair of electron attack on the carbocation, and you will get over here CS3, 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 and over here O is giving the both electron to him, and this H and this H. As oxygen has given his lone pair of electron, so oxygen get positive charge. Previously carbon has positive charge, but now oxygen has given his lone pair of electron, so oxygen get positive charge. Now after having the positive charge, we know that positive charge on more electronegative atom is less stable. Positive charge on more electronegative atom is less stable. It means they want to reduce the positive charge, so it will take the electron from hydrogen and H will remove from here, and X minus is waiting over here. It means HX going outside, and the finally you will get over here CS3, 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 over here O and H, and this is the all about mechanism. But after doing the mechanism, we will come to know about that over here there is a intermediate, and that intermediate formation is carbocation. And carbocation has some property, and that property is known as, first thing, that 3 degree is most stable than 2 degree is most stable than 1 degree. Second property of carbocation, that it can do rearrangement. It can do rearrangement if possible. It can do rearrangement if possible. I will tell you how it will do the rearrangement if possible. Just understand the things what I am trying to dictate properly, so you will not get confused. First of all, this is the mechanism of SN1. Regarding the rearrangement, everything we will go further, but right now everyone understand mechanism. Suppose I am going to write the mechanism again with the different things, reagent. Suppose I have taken over here, firstly I am doing CS3, CS3, CS3. Suppose I have over here taken Cl, this will remove from here, and because electronegativity of Cl is greater than electronegativity of carbon, so it will do hydrolytic fission, and because of hydrolytic fission, this is the first step, and the first step is the slowest step, and slowest step is the rate determining step. From here you will get the things like CS3, 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 positive charge, and over here Cl minus will be out. On that positive charge, you can say over here you will get the intermediate as carbocation, and carbocation is 3 degree greater than 2 degree greater than 1 degree, as well as rearrangement if possible. Now suppose in place of H2O, CH3OH will come. Now O has a lone pair of electron. This lone pair of electron attack on carbocation, and you will get over here CH3, CH3 over here O. With that O, one side H, one side CH3. This is the things previously both side H, so I have written H. And now this oxygen has given his lone pair of electron, so it will get positive charge, and most electronegative atom is not stable in positive charge, so it will try to take the lone pair of electron from hydrogen, because it is easy to take the lone pair of electron from hydrogen. And from here you will get the things like CH3, CH3 over here O, CH3, and H will remove, and this Cl is waiting, and HCl is going outside. So this is all about the mechanism of SN1. Now after having the mechanism, we will understand the stereochemistry of SN1. Does I have to write some more does I have to write one more example while doing the mechanism? Do you think so? No, sir. If you think like that, then over here I will take the same thing. Over here I will remove the things from here, and I will write. You have written the previous part. If not written, write it. Suppose I have taken over here C3H7OH. Now this lone pair of electron attack over here, and because of that, one side you will get H, one side you will get C3H7. So from here H will remove, HX will remove, and over here you will get C3H7. So same thing everywhere. Getting my point? Same, just I have removing the things. First step is the same for everywhere. Second step, either they will give you H2O, or they will give you CH3OH, or they will give you C3H7OH. According to that you will have to do and write all the things that I have written over here. Now I am going to erase, and now I am going to give you the important point regarding the SN1 mechanism. Everything written this part. Can I erase this one? Everything written? Okay, sir. Fast. Now I am going to erase the first one. This I am not erasing. So after seeing this, we will write the important part regarding that. Important part is known as stereochemistry of SN1 mechanism. That important part is known as stereochemistry of SN1 mechanism. Sir, able to understand, sir? Seriously tell me. Any confusion? No? For sure. If you find it confusing, tell me. This video I am going to make little bit lengthy, more than 1 hour, but trust me, this will help you a lot. After watching this video, you will feel very comfortable. Oh, sir, and now I am able to understand Lucas reagent and SN1 mechanism. The first point, what we have seen, that it is a two-step reaction. It is a two-step reaction. First step, and this is the second step. Now, first step is slowest step, and second step is fast step. It means from here the second point you can write, first step is slowest step, and third point you can write, second step is fastest step. Now fourth point you can write that slowest step is known as rate determining step, and it is written in the short form RDS. It means slowest step is known as rate determining step, and we know that the first step is slowest step. So first step is rate determining step. Is there any problem up to that? For sure. Okay, sir. Write fast. I will erase line by line because I didn't have that much space. Now, in the first step, what you have seen, that fifth point, in the first step, have you seen anywhere nucleophile? It means, have you seen H2O, CH3OH, C2H5OH? No. It means you can write the rate is directly proportional to the concentration. This bracket will show concentration of alkyl halide to the power 1 and nucleophile to the power 0. It means in the second step nucleophile is attacking na. This is the first step, so we have this one now only, sir. This is the first step we will have na, sir. This is the first step we will have na, sir. In the first step, is there any nucleophile participation? No. In the second step, there is a participation. And second step is very fast. So we are not considering the second step. So in the first step, rate is only depends upon alkyl halide to the power 1. And anything to the power 0 is considered to be 1. So from here, you can write rate is directly proportional to alkyl halide to the power 1. And it depends only the alkyl halide to the power 1. So because of power 1, because if nucleophile also power 1, so 1 plus 1 became 2, but nucleophile power 0 overall became 1, so removed. 1 is no need to write, na, multiplied 1 no need to write. So nucleophile is not taking part, only alkyl halide is taking part, and power is 1, so it is known as first order nucleophilic substitution reaction or unimolecular nucleophilic substitution reaction. Do you know why it is called first order or unimolecular? Yes, sir. Now I come to you. Now from here, if I am going to ask you one question, that what is the effect on rate of reaction when we change the concentration of nucleophile. Now I am asking, suppose I am making the concentration, previously I am taking the concentration of nucleophile as 10 ml suppose. Now I am going to take the concentration of nucleophile as 20 ml. So does it affects on the rate of reaction? No, no effect. Why? Because SN1 will not depend upon the concentration of nucleophile. Write fast everything that I am writing over here. It means we can say that if the concentration of nucleophile change, there is no change in the rate of reaction. But if the concentration of alkyl halide became double, then the rate of reaction became double. Triple, then triple. 4 times, then 4 times. If the concentration of alkyl halide became half, then the rate also became half, because it is directly proportional to the power 1. Getting my point? It means there is no any effect of nucleophile. It means from here you can write one point, that there is no any effect of nucleophile on the rate of reaction. It is not meant that it will not affect on the reaction. It will affect on the reaction, but the reaction is going very fastly or slowly. That will not decided by nucleophile. It means rate of reaction will not define. Rate of reaction will not defined by nucleophile. There is no any effect of nucleophile on the rate of reaction. This point written. Now can I erase this point? Understand up to this? Write fast. Now the 6th point you can write. The intermediate formed over here is carbocation. Can I erase all the things? Everything? Okay, sir. Written? If not written, then go previously, pause the video, take the screenshot. But trust me, after knowing this, you will be 100% sure regarding SN1 mechanism. But still you find difficulty, please tell me. I am just like your elder brother. If you treat me, I am just like your elder brother. Now, 5th point. Point number I am forgetting, 5th or 6th. I am writing 6th point. The 6th point is saying that before going with the intermediate formed is carbocation, one more thing is there. There is a solvent called polar protic solvent. Over here the solvent we are using like H2O or CS3OH or C3H7OH dash 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 ROH or NH3 lone pair or RNH2 or R2NH, whatever with the reagents we are using over here, that reagent is polar protic solvent. That reagent is polar protic solvent. What do you mean by polar protic solvent? Suppose I have taken H2O. Polar means, suppose if you write it, you will get HOH. and it has a polarity. It will get positive, it will get negative. Polar means polarity. And because of the polarity, H2O is break as H plus plus OH minus. What do you mean by protic? Protic means, suppose over here Cl will remove and it will become carbocation. Now, in the first step, before going to the second step, why not this Cl is again attacking with carbon and became this product? It will happen, na? Suppose the Cl is removing from here. Now it will get positive charge. Now this Cl is weighted to hydrogen to come outside, and then the Cl will attack over here, and HCl will going outside, and CH3OH will attack over here. Before doing all this second step, this Cl will attack with this carbon and again became this product. Why it is not happening? Because of the things that is known as protic. What do you mean by, sir? What happens once the Cl minus will remove, na? So it will try to attack again with the carbocation, but H2O will come over here and it will form the cage-like structure. It will form the cage-like structure. This is known as protic, means cage-like structure. And due to the formation of cage-like structure, Cl is stuck in between the water molecules and it is not going to attack over here. Now, the lots of water molecules or lots of CH3OH molecules, now they will make the structure, cage-like structure. Cl is inside that. Please leave me, please leave me. Before it is leaving, it will attack on the carbocation and form the product. Now, after that, hydrogen remove and say Cl, take the hydrogen and goes outside as a HCl. It means this is all about polar protic solvent. Now, the next point, and that is very important point, can I erase this? Is known as, if you see over here, in the first step is known as rate determining step, and in the first step there is a formation of carbocation. That is very important, that the intermediate formed is carbocation. The intermediate formed is carbocation. Carbocation means a carbon has positive charge. Carbocation means carbon has positive charge. Now, everyone, I have already dictated you that this carbocation is 3 degree greater than 2 degree greater than 1 degree. As well as one versatile nature, one very important property of carbocation, that it can do rearrangement if possible. It can do rearrangement if possible. What do you mean by that, sir? See over here. I am trying to say, suppose I have taken one example, CH3, CH, CH3, over here CH2, and over here X. Now I am saying write the SN1 mechanism for this reaction. Write the SN1 mechanism for the given reaction that I have written over here. So what you will do? You will say, sir, the electronegativity of X is greater than electronegativity of carbon. Because of that, it will do the heterolytic fission. And from here, there is a first step, and that first step is slowest step, and the slowest step is rate determining step, and in that rate determining step, what you will get? CH3, CH, CH3 and CH2 plus. Now you will say over here that the intermediate is carbocation, and carbocation has two property. First one, 3 degree greater than 2 degree greater than 1 degree, and second one, if possible, rearrangement can occur. If possible, rearrangement can occur. Now there is a possibility. In this, the carbocation is formed already in 3 degree, but over here the carbocation is formed on 1 degree, and just adjacent to that, there is a 3 degree. So what happens? It will H. Now, whenever we will do the rearrangement, in the rearrangement we will do either H minus shift, or we will do pH minus means phenyl, means benzene ring with negative charge. Phenyl shift, or we will do CH3 minus shift. So over here CH3 is also there and H is also there. So which will shift? The first H. If H is not there, then pH. If pH is not there, then the CH3. Now over here, if you see that there is H and this carbocation, just adjacent to that carbocation there is a 3 degree. So what happens? This is the first time where hydrogen is taking the electron, and because hydrogen is taking the electron, it will get H minus. Now this H minus attack on this carbon, and because of attacking of the H minus, it means over here you will do rearrangement. The rearrangement is only done when the carbocation formed is not on 3 degree, and just adjacent to that there is 3 degree or 2 degree. So just adjacent to the formation of carbocation there is 3 degree. So rearrangement happens. What happens in the rearrangement? The CH3 is there, the CH3 is there, H minus will attack over here and CH2 became CH3, and this plus comes over here. This plus comes over here. Now after having the rearrangement, the second step, now in the second step there is an attack of H2O, and that H2O will attack over here, not this carbon, and now you will get CH3, C, CH3, CH3, O, H, H. Now this oxygen is get positive charge. Because of that, it will take the lone pair of electron from hydrogen, and H will remove, and from here minus H, Cl or X I have taken, to minus H, X will form. Now what happens? You will get over here C, CH3, CH3, over here OH, over here CH3. So this is all about the rearrangement. This is all about the rearrangement. I will do one more question regarding rearrangement. Can I erase all the things that I have written on the board? Okay, sir. Erase it. Erase it, sir. Now I am going to do the rearrangement for Lucas reagent. Now I will dictate you all the things of Lucas reagent also regarding this. Don't worry, sir. Don't worry, sir. Don't worry. I will dictate you all the things. Now, Lucas reagent, what you have seen over there in the Lucas reagent, what you have seen, how many time I have completed up to now? It is going to be 42 minutes. Okay, I will try to complete as fast. Now in Lucas reagent, if we will see over here, what we are saying, that in Lucas reagent, the reagent is HCl or ZnCl2 or HCl plus heat, or only HCl is given, and this will follow SN1 mechanism. This will follow SN1 mechanism. So suppose I have taken over here CH3, CH2, and over here OH, and it is reacting with HCl in presence of ZnCl2. In this Lucas reagent already told that if there is 3 degree alcohol, you will have to learn this part directly. It will give turbidity immediately. It will give turbidity immediately. Turbidity means white precipitate. Second point, if 2 degree alcohol is there, it will also gives turbidity, but 5 to 10 minutes it will take to give, that is turbidity means white PPT. And if it is 1 degree alcohol, then it will never give turbidity. This part you have to learn directly. Now what you will do over here, you will say, sir, this OH minus will remove, because of that it will get positive, and this positive is the intermediate, then you will get over here CH3, CH2 plus, and now from here the Cl minus will come, this H plus, Cl minus, this H plus attack over here, and there is a removal of H2O. First step is carbocation. Now Cl minus will attack, and you will get CH3, CH2, Cl. But in place of this, if I have written CH3, CH2, CH2OH, now like this, like this. Now if you see over here, if you are using HCl in presence of ZnCl2, what happens? This OH minus will remove, and this H plus Cl minus H plus will attack, and H2O will remove. Now what happens? It will get positive, and you will get in the first step CH3 CH2 CH2 plus H2O is removing H2O. Now over here what you will see, that the carbocation formed is on 1 degree, just adjacent to that there is a 2 degree. So what happens? One hydrogen, I am writing like that, this hydrogen is taking the electron and get negative, and this attack over here, and after this you will get CH3 CH, CH2 became CH3 because H is attacking, and the plus come over here, then over here Cl minus will attack and goes over here CH3 CH CH3, and over here Cl. Suppose I have taken another example. Suppose I have taken another example like this. Now you are able to understand why Lucas reagent rearrangement is needed. Suppose I have taken CH3 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 CH2, and over here suppose OH. Now what happens? First HCl in presence of ZnCl2 you will react. Now this OH will remove from here, it will get positive sign. Now after getting the positive sign, this hydrogen will get positive, Cl will negative because H2O will remove. Now you will get over here CH3 CH3 CH3, over here CH2 plus. Now there is a problem that with just adjacent to that carbocation there is a 3 degree, but with this 3 degree is there any hydrogen? No. So which will shift? CH3 minus will shift. Now in this case CH3 minus will take the electron and goes over here. So what you will get? CH3 CCH3, this CH2 positive gone, and this CH3 come over here, and this will get positive. Now Cl minus will attack over here. Now Cl minus will attack over here, and you will get CH3 C CH3 CH2. I am writing this part in the above, so you written this part fast. Okay. Understanding now, after understanding SN1 mechanism, you will come to know what I am trying to dictate in detail. Now from here what happens? The Cl minus will attack after having the rearrangement, and you will get over here CH3 Cl over here, CH3 CH2 CH3 over here. Getting it or not getting? Suppose I am going to take another example, CH3 CH CH3 CH2 OH over here. Now in presence of HCl ZnCl2, what will happen? This OH minus will remove, there is a H plus, Cl minus reacting it with H2O getting outside, this will get positive sign. So you will get over here CH3 C CH3 H over here, CH2 plus over here, just adjacent to that there is a 3 degree, it will remove as H minus because H is there previously, H is not there, so I am removing CH3, H will go over here and became CH3 C CH3, CH2 became CH3, and the positive from there come over here. Now Cl minus will come and it will goes like this, C CH3 CH3 over here Cl. Getting my point or getting totally confused, sir? Tell me fast, tell me fast. Seriously, you are getting what I am trying to dictate, or you are getting totally confused? No sir, we are getting all the things that you are trying to dictate. Now some more thing I have to dictate regarding SN1 mechanism, but it is still going to be 40. How many minutes we have completed? We have completed 48 minutes. So I will make the video in 01 and 02, so you will not get confused. Getting my point? Or I will try to make it over here. 1.5 hours is good or going to be complicated, sir? Tell me, what would I do? Can I one more little bit thing I have dictated? 90% I have dictated, 10% I have to all dictate more. Okay, dictate it, sir. Write fast. So now you understand 90% things regarding SN1 mechanism and Lucas reagent. Now we will have to proceed. If there is a chiral carbon, then what happens? Okay, sir, come over here. Every college is, or every coaching, we will have a 1.5 hour class, so you can also teach me 1.5 hour. Then we will not have the problem to understanding the things. But trust me, if you revise the things very properly, very properly, then you will not find any difficulty in SN1 as well as Lucas reagent. Now up to that you are able to understand what I am trying to say? Yes sir, we are able to understand. strand. Okay, sir. If you are able to understand, now come to the next thing, that is if there is chiral carbon. If there is chiral carbon. Now question arises that I will make that in the next video because it is going to be very tough for you. Okay, otherwise you will get confused. Already you are very much weak in organic chemistry and I don't want to make it very larger video. Okay, then bye, have a nice day, enjoy, take care, stay home, stay safe. This just after that I will dictate another video. Getting my point? Bye, have a nice day.